Thank you very much, everyone. So now we're going to do something similar but yet different, so no voting for this next session. So because we're going to invite, we're going to invite some of our CS3 faculty to give their lightning talks. We're giving them a little bit more time than the NSF perfect pitch format. So I wanted to invite Jason Hallstrom, who's the Deputy Director of the CS3, the center. Jason is from Florida Atlantic University. He's the founding executive director of FAU's Institute for Sensing and Embedded Network Systems Engineering, iSense, and he's a professor in the Department of Electrical Engineering and Computer Science, and also a great deputy director. So welcome up and to moderate this next session. And our first speaker is going to be Carl Vondrick. I don't know if you want to do the introductions. Oh, you'll have them do it. Okay, so then I'm going to just launch your presentation. Sorry about that, Jason. All right, welcome, Carl.
Okay, hello everyone. My name is Carl Vondrick. I'm a faculty here in computer science. I work in computer vision and machine learning. And I was going to talk to you about some of the recent work in computer vision our lab has been doing in collaboration with this center. So, I mean, we all see AI everywhere today, right? With text and with vision, we can recognize objects, and self-driving cars are right around the corner, and they're able to recognize pedestrians and so on. One of the most challenging problems in vision is due to occlusion, right? You can't always see what's going on, right? When you're on the streetscape, there's lots of occlusions, right? Just in New York City, there's just pedestrians and cars, and you always just see partial bits of each object. So, when you're looking on the vision problem, some of you might be saying, well, if you just can't see it, you can't see it, right? There's not enough information here. You actually can't determine what there is. But no, we actually all look at this image, and we have some common sense, and we know there's not just one cow here, right? We're smart people here, right? We know, okay, probably there's a cow here, and probably that cow looks something like this, right? So actually, this ability is a really, this is a kind of something that evolution has discovered from a very, So this is called the What the Fluff Challenge on YouTube. Who has a dog in their room? So you can play this with so all the dog people are over here. That's interesting. So you can play this with your dog, and dogs have this really intuitive notion of physics, that they know when something is not visible anymore, they know it must still exist. So they freak out when this gets violated, right? They freak out. But this ability dogs have, 2-year-olds have, chickens have, crows have. But it's really difficult to actually build machines that have this type of capability. It's these abilities that are so easy for toddlers. It's actually really difficult to build inside of machines, but it's critical. This is an ability that is obvious to us. We don't get a headache thinking about this. We just know, okay, these objects and people still exist even though we can't see them. So one of the challenges here is basically an issue of data. You basically need to build visual systems that can reconstruct our environment in 3D, right? When you take a photo, what you're getting is the projection of our 3D world onto a 2D plane, right? And one of the challenges here is, well, there's just not as much 3D data out there, right? There's on the internet and from cameras, lots of 2D data, which is driving a lot of progress in machine learning and computer vision today, but much less 3D data. So I actually did pi r squared correctly here to get the circles to be the right sizes, and just see how much little 3D data there is, right? So we've been developing approaches that try to actually build 3D representations and can solve this occlusion problem by combining both, right? It actually learns from both 2D data and 3D data to do this. And we've made some good progress on this. This is a system that actually can, given a single image, can reconstruct that object in 3D and move the camera around from just a single view. Pretty good. It's not perfect, right? If you look at the drum, there's some errors there, but pretty good progress there. It even works on art, so it works on totally unconstrained. types of objects, and you can move the camera around even things that shouldn't be in 3D, right? This is actually a 2D concept. What's really interesting about this approach is it actually can start to handle some types of occlusions. I love the chair example here, where it actually can reconstruct, right? Even though we can't see the full chair, actually can reconstruct that full object and allow us even to move the camera viewplane around. So I think this will be critical for anything in a smart city where it's just there's a smart street where there's just lots of occlusions all the time. We don't always get it right. There's still some, this is a hard problem, still some physics is missing here. So for example, we reconstruct that car on the left as driving the wrong way. If you think about this for a moment, you realize that that car actually should be driving to the left, not to the right, right? So it's missing some of this basic common sense, and even just some physics here, right? It's the only way that donut box could be supported is if he's actually holding the donut box, but our system doesn't understand that, and it thinks his arm is somewhere else. So more broadly, we've been looking at this from multiple different scales about trying to build vision systems that can make sense of all the different types of data we're able to capture. This is ranging from images on the ground that people might take. This could be from surveillance cameras around the city. It's also opportunities, for example, to use drones and satellite data. And can you combine all of this to build a global representation as to what's happening inside of a street or inside of a city? So I think this is a really exciting opportunity here. I think there's a lot of discussion today has been about this, as what are the opportunities, what are the risks here. And this is something that I'm really excited about the center to engage with everyone here is what are the applications and the opportunities here, and a lot of interesting problems that you have about and what people have about our streets or about our city that we want to develop can actually motivate really interesting technical problems in computer vision. So building that dialogue, I think, is very important. So I've actually been enjoying this day to actually establish more of that dialogue. Okay, that's all for me. Thank you.
Thank you very much, Carl. So next up, 1 second, is, we think it's Sharon, or you think it's you? I really don't mind. Okay.
If you like the moderation I'm doing so far, you're gonna love it.
There we go.
Good morning, everyone. So I have to appreciate that. So today I will talk about, because this session is about digital twin, I will talk about how we develop an urban traffic digital twin to improve mobility for all. So I think everyone has your own definition of what digital twin is. Here, I just present the architecture of our digital twin. We start from physical world, leveraging the Cosmos testbed that deployed near Columbia campus, mentioned by Andrew this morning. So in this physical world, we deployed many sensors. Most important one are cameras and edge cloud computing. My collaborators have parsed all these images and tried to do the object detection and tracking as well as trajectory prediction. And then they convert this position and timestamps and hiding of these objects into so-called MQTT messages, which is the standard protocol for IoT device message nowadays. So we believe this is not the whole picture of a digital twin. Instead, it's just the eyes. Basically, the digital twin can see better relying on these sensors. And what's really more important, what can we do with these messages? So from a domain perspective, as a transportation engineer, we are interested in how we can predict, estimate traffic conditions, creating a virtual identity of the world. Here is the intersection just near Columbia campus, and then run different use cases, including the safety warning, traffic signal control, autonomous driving, and eventually these signals or activation how to feed back to the real world. And we believe this is the brain of the digital twin, and it's important to use data, use simulation, and as well as AI. But to make it work and add values, we rely on technology enabler here. As I mentioned, we use Cosmos Testbed. So probably some of you already had a tour yesterday. So this testbed has already set up a lot of things. And here, and it spans different applications. I just want to highlight what transportation application we can leverage. And I want to draw your attention to the lower pictures. Basically, we leverage the 2 cameras on the ground and second floor, as well as the bird's eye view 12th floor camera that hangs in the mud building at the intersection of Amsterdam and 120th Street. So I will show you what values we can add using the digital twin and this Cosmos testbed. So the first case study I want to mention here is the pedestrian vehicle crossing safety warning app we have developed. So this is the web version of that app. So with the bird's eye view camera, we leverage only the 12th floor for this application. You can see we can, using the identified objects and the trajectory prediction, we can make a prediction and warn the policymakers or operators about potential risk. And here is the high school student actually worked with us last summer. He developed a smartphone app. So basically here, he risked his life trying to test how reliable this app is. So for example, now it's red light, but he tried to jump into the sidewalk when a car is approaching. Here's the black dots on the left-hand side. That's where he can see on his phone. And then this car passing by, so it shows because from the camera it detects he's about to cross. So that based on the prediction, there's a warning issue. But when this UPS truck is passing by, he stopped. So that's why there's no warning anymore. And then the second use case we want to focus on is how we can coordinate all these traffic lights along a corridor, say Amsterdam Avenue, so that we can smooth traffic flow out. So we use so-called federated learning technique, which can protect the privacy for the device when they don't have to transmit the data to the central controller. Instead, they do everything local. That can not only preserve privacy, but also reduce communication cost. So before and after training, you can see that we reduce the total traffic delay over this Cosmos testbed by 30%, and also the communication cost between individual traffic signal controls and the central control is reduced. So before I close my presentation here, I want to talk about one last topic that is ongoing right now. It's the aging in place. So as we all know, by 2034, so the population of older adults will outnumber the children for the first time in history. And based on Vision Zero report last year, you can see the older pedestrians are more likely to be killed or severely injured compared to non-older adults. So that's why we are very interested to make cities more walkable for older adults. And not only that, also for other people, for disadvantaged communities who are normally not considered in urban design context. And then this map shows the population density of older adults near our neighborhoods. And we are working actually with professor in medical school as well, trying to reach out to all the communities in these 2 neighborhoods, and then identify people's needs and obstacles by using technology like VR, AR, and also simulation. And here we are seeking partnerships with the industry and also the agencies to see how we can help with analyzing data, build models, simulations to make mobility better for all. Thank you.
Thank very much, Sharon. So next up is Brian Smith from our Department of Computer Science. Take it away, Brian.
Install a virus on Andrew's laptop. All right, perfect. My name's Brian Smith, and I'm in the computer science department here. I'm one of the researchers within the center, and so the purpose of these lightning talks is for us. I meant to grab a mic. Awesome, yeah, so the purpose of these lightning talks is for us to give you a peek at some of the cutting edge research that we've been doing and what we've been thinking about within the center. So in that realm, I'm going to be talking about applications for streetscapes. And if applications is a strange word, you can replace that with the word purposes. What purposes should streetscapes serve? So I'm a computer scientist by training, but I care about human problems. I'm really fascinated by the fact that with smart city technology, we have all of these intelligent computing possibilities, sensors and cameras and things like that, but for them to really have an impact on being human, on just daily life, they need to share those abilities with people. Impact is synonymous with experience. If we are to make an impact with the technologies that we develop, we have to change people's lived experience. And so I think a lot about daily experiences from technologies. So I think of technologies as computers almost like actors in a stage play, where they, with all these different sensors, I'm replacing all these actors with chips, they're putting together a great performance for the audience. They're giving the audience, the user, a great experience. So that's how I think about coordinating technologies to actually create good experiences for people. Likewise, these days computers are everywhere. We are already seeing smart homes, and then even within these cities, so many of these things that in this busy street, in this intersection here in Harlem, are actually becoming computers. So from the crossing signal to the street itself to automobiles, garbage management on the bottom left, etc. So we have to think about how can all of these pieces actually coordinate and work together to enable great purposes and great experiences for users. So I've been doing that along two lines so far. One is on access, actually fostering inclusive cities for the broader community, and then the other is on connection. How can you connect the people who live in cities with each other and with their communities and community histories? So in the realm of access, I've done a lot of work with folks who are blind or low vision. This person here has been blind his whole life. And within my lab, we've done a lot of work on, for example, making video games equivalently accessible to people who are blind or low vision. Work such as this, where this was maybe his third time ever racing around this racetrack, we're actually giving him new audio and haptic cues to really understand what his car is doing, what the racetrack is doing. This technology has been deployed in actual video games. So just in the fall, Forza Motorsport has a blind driving assist mode based off of our research. And so within the center, we've been thinking a lot about how can actually we take this thing to the next level and move away from video games and towards making our actual cities accessible to people who are blind or low vision or mobility impaired. And so one project that we've been doing is about repurposing street cameras. Here I'm showing a street camera view for the purpose of accessibility, in this case for blind and low vision folks. So these street cameras have the ability to perceive people and anonymize them so that our downstream systems that actually use these video feeds only get to see the bounding boxes and the number, no identity. And so we're taking advantage of that, and we're actually helping, here in the corner, a blind person navigate. They wave their hand to register themselves with the system, and then they have a smartphone app that's giving them turn-by-turn directions to locate different points of interest within the street. So you can go to different buildings, bus stops, benches, etc., and they're actually getting real-time navigation assistance. That includes from existing street cameras, that includes the ability to actually cross the street safely, walk straight. People who are blind tend to veer if they can't follow an edge with a white cane. And so the street camera actually does this by, actually I want to go back real quick. The street camera actually does this by looking at the signal and telling the user when it's okay to cross. But the signal itself is often not enough. If you look here, the signal turned to, this is New York, traffic lights are a suggestion. And so this signal it's ready to cross, but obviously it's not. There's even a bike here. And so we also use the street cameras to detect other obstacles in real time to help users. So here's that same truck passing by. The signal changed. On the top right, there's a little zoom in on the signal, but only when everything's actually clear will the system actually help the user. And then on the connection side, we've been engaging as part of the center and these community partners and residents workshops, and one of the big takeaways for me from this is there's a need for people to connect with their community's history, for that history to not be wiped away as cities expand, right? So that's been really important. And so I've had experience at Snapchat as a research scientist working on these spectacle smart glasses and doing a lot of AR and social projects. How can we use some of that experience to help people connect with their communities? So we've done things, this was back at Snapchat, where folks are recording video here, and then that can be replayed as an immersive memory, on location in different parts of, in different environments, in different settings. What can we do for cities to help people connect with cities? And so one concept that's still early that we're exploring is what if community members can actually snap photos of different parts of the community and annotate them, right? So this is work that actually Snapchat has been doing in London, but we're thinking of doing this sort of thing for Harlem and for other communities, in cities here in the United States. And this might be, a system like this might be attached to a map where every time someone annotates some history or whatever, each one of these points of interest actually has an associated discussion and comments that people can keep the conversation going around that. And then another idea that we've been playing with is this concept of talking photos in buildings. What if murals and storefronts and apartment buildings could come alive and actually tell their stories, or if people could peek inside different buildings in the city and actually see what's happening inside without needing to go in? How can cities reveal themselves and become more alive and active to people passing by? I'm going to close with this. These days we have so much open data here in New York City alone with NYC open data, everything from like motor vehicle collisions to taxi rides and et cetera, parking tickets, all available. But there's a disconnect where you have to be tech savvy to be able to see a lot of these databases. Can we use AR and better tools that are actually on the street itself to give people a better glimpse of what's going on in that community, and so that we can sort of sense what's happening within the community and get more public input and engagement around how we are evolving city streetscapes. There's this example in Toronto of a public screen that as people wait for a bus stop, they can actually queue up YouTube videos. We've been thinking a lot about public displays. And so here, I'm just going to throw these on here. I'm good at finding good purposes for technology, human-centered design, social apps, and I'd love to chat with folks here, about, well, what real-world problems do we think that smart streetscapes can actually address, as well as connecting with users and even compute power to make these sorts of things happen. Thank you so much.
Thanks very much. Thanks very much. So every time we have a chance to see our team present, I walk away thinking, oh my God, this is amazing. What an amazing, no thanks, I'll talk loud. Can folks hear me? Okay. I always think, what an amazing center to be a part of. So we heard first from Carl on the foundations of visual analytics and computer vision. We then heard from Sharon and how those foundations are applied in the context of digital twins. And then we heard from Brian on how, on top of that, we can build these incredible new streetscape applications. And so what we're going to talk about in the final talk is, where do we apply these mobility testing ground. So I'm going to give you just an overview of what each of those test beds is about. So we're going to start with the Cosmos test bed. The Cosmos test bed is currently our most advanced test bed. This test bed is deployed in Harlem. It covers approximately 15 city blocks. It's about 1 square mile. It runs from Columbia's Morningside campus all the way up to the City College of New York. So it covers a large geographic area. Now this is an experimental test bed. It's designed for experimentation by the community. It's actively used by our industry partners. This is a multi-tenant, shared use, wireless, optical edge test bed. It's built on 4 enabling technologies. The first is software-defined radio, software-defined networking. The second is millimeter wave radio. The third is optical networking that spans tens of miles of dark fiber, connecting Columbia to the City College, to assets at Rutgers and other assets across the community. And finally, tightly integrated edge compute resources, accelerators, FPGAs, etc., that allows us to do some really exciting experimentation at the confluence of wireless technologies, edge and cloud compute. I want to talk a bit about what Cosmos is enabling in terms of collaboration with our industry partners. The first is that very recently, Cosmos was named as an OTIC, OTIC. This is only one of 2 North American open testing and integration centers specifically designed to support the advancement of O-RAN. And so this is a new proving ground that's available not only to the CS3 team, but also to some industry partners that allows for testing and verification, validation of O-RAN technology. And of course, that specification compliance is fundamental to the broader adoption of O-RAN. We're also using Cosmos to exfiltrate data from the test bed and to provide that data to external partners who can use that data in interesting ways. So one of those applications is with a partner, KentU. I'm not sure if KentU is here today. We have KentU here today? No, we don't. So KentU is using data that's exfiltrated from Cosmos, that's captured from cameras, runs through our computer vision system. And the data is fully anonymized, so we're capturing information about, again, where are the pedestrians, where are the cyclists, where are the entities within the streetscape, providing bounding box information and classification data over to KentU, who's then able to integrate that within their smart city dashboards, which then becomes a service to the municipalities and to our stakeholders. Perhaps the most advanced collaboration that we've had so far in the context of Cosmos is with partners NEC and NTT. And this was a study that was looking at shared use of the underlying optical fiber on which Cosmos is built. So looking at how do you use that optical fiber simultaneously for very high bandwidth communication and very high fidelity sensing. So you're able, with this optical fiber, to be able to sense changes in vibration, changes in deformation, and that's of course useful in being able to understand traffic patterns. It's also useful for proactive maintenance. So if you see an anomalous event through that vibration sensing, then you may be able to make alterations in the underlying pathways to avoid future disruptions based on what you saw. And what this initial study found was that you're able to achieve very high bandwidth, upwards of 500 gig connectivity across that fiber while using it simultaneously for sensing, as well as for analog over fiber or 5G front haul. Our second test bed is deployed in the heart of downtown West Palm Beach. It runs along about 700 meters along Clematis Street, which is the heart of the downtown corridor in West Palm Beach. This is a different kind of test bed. It wasn't originally designed as an experimentation test bed. It was designed as a production test bed to understand in a fine-grained way where do people want to go, how do they get there, and what are the challenges that they may face along the way. This test bed works based on wireless sensing. So it's focused on capturing MAC probe requests emitted from cell phones. Those are fully anonymized. And then through a combination of signal strength measurements and machine learning, we're able to identify with reasonably high accuracy, within a radius of approximately 4 meters, where the pedestrians are in a real-time anonymized way. Since this test bed was first installed, we've collected over 1 trillion probe requests. We capture about 1.1 million probe requests every week. It's about 1 terabyte worth of data. And I'll talk just a designed by Google Street Lab some time ago, and this is just a crowdsourcing application that's used quite broadly, not this specific application, but applications of this type are used quite broadly by urban planning folks to count effectively through volunteers, where are the pedestrians, how many are there, how many vehicles were there, were they turning right, what is perceived gender, and so on. Much of that can be automated through systems like this, and that's where we're moving with this test bed. Now, of course, to be able to automate that, to understand in a more fine-grained way where the people were, the cars were, the cyclists, and so on, we can't do that using Wi-Fi probe requests alone. We're going to need something more. We're going to need computer vision to do that. We're going to need LiDAR to do that. And so we're in the process of integrating some of that technology within the streetscape today. So our partners are quite interested in how can you fully automate the collection of the data that's needed for urban design, for urban planning, without needing hundreds of volunteers, the cost, and also the inaccuracy. So that's where we're moving with this test bed. Our third test bed is our Data City Smart Mobility Testing Ground, and this is deployed in New Brunswick, just outside the Rutgers campus. This test bed spans approximately 2.1 miles. So this is a 2.1-mile stretch of Route 18 that runs just outside the Rutgers campus and then comes down into the campus, into the heart of the downtown. That's about 2.1 miles of roadway. Now this test bed includes specialized sensing and control capabilities specifically designed for roadway applications, for automated vehicle testing, and so on. So this includes today 36 4K RGB cameras, 18 64-channel LiDARs. Those devices are connected to 36 local edge compute processors, high-performance computing, accelerators, and so on. And these are all integrated within roadside packages. Now, all of the data that's being collected through that system is being fed back to a data center that's housed, a new data center that's housed on the Rutgers campus, just at the end of that 2.1-mile stretch. And this is being used to populate a digital twin of what's happening along the full reach of that 2.1-mile roadway. Now today, the majority of the communication is focused on 5G vehicle-to-everything communication, but there are obvious opportunities here for us to integrate the advancements that are being achieved in the Y-Edge thrust, in the Y-Edge component of the center, within this test bed. Now in terms of collaboration opportunities, this test bed has an enormous amount of data that's being collected along that roadway. That data is available for sharing. There are, of course, opportunities for digital twin services, digital twin testing, data processing and labeling, as well as test user recruitment. This test bed will also eventually include 4 connected autonomous vehicles. With that, I'm going to wrap this up, and I'm going to invite our presenters back to the stage, and I'll just ask folks to take a seat up here, and we're going to open the floor to questions. I have a couple of questions I'd like to start with. So we have this incredible opportunity here today to talk with folks from industry, and we have a great collection of students here today. And so to get the conversation started, I'm going to ask each of our panelists where they see, actually, to interpret this as you'd like, where do you see the greatest opportunities for collaboration with industry that could help to accelerate your research? And then I'm going to come back and ask a similar question about students. And so, Carl, I'll turn it to you first.
Sure, that's a great question. I think a lot of it is just what are the practical challenges that there are that you don't know how to solve, that we can potentially solve, and just identifying those. And I think a lot of the most interesting questions in computer science and in machine learning now are actually trying to overcome some of the physical issues and challenges that actually happen in practice. So that dialogue, I think, is very important.
Yeah, I think this center lives on making making things real for people, having an impact on technology. And so I concur with Carl. I think to keep ourselves grounded, it's important that we actually hear about like what problems everyone from industry is facing, so that we can work together to, okay, well, are there any clever new ideas or any way that we can actually address that? Keeping us grounded in real problems is important. I also think there's a chance for industry to I think there's a chance for our students actually for there to be a pipeline between our students and industry as well, either through internships or through extended collaborations. I think there could be a great way of getting ideas prototyped and built here in the university that might be too costly at companies.
Since I'm a transportation researcher, so I will talk about how we want to work with the cities, with industry to help with the traffic problem. So as we all know, traffic in New York City is bad. Even we don't drive, we take subways, the subway is bad. So we are looking for definite data, and because DOT, we are in active conversation with DOT about also accessing their cameras, because agencies have a lot of data we don't have, that if we can help with the analysis and also do the modeling or simulation, hopefully we can provide some solution to work together with the DOT, with also the communities, so that everyone's voice can be heard. Thank you.
Thank you all. So I'm going to ask one more question before I open it up to the folks in the room. So again, many students are present here today, and this center is unique in its breadth, not only of technical areas, but in areas that we might not normally think of as being part of the engineering space. So we have deep connections to the social sciences. We're doing a lot of work with our industry partners, community engagement, and these things are areas that engineers typically do not get involved in. So for our students, is there a particular bit of advice that you'd like to share with them in terms of how do they best leverage CS3? And Brian, I'm happy to start with you.
Okay, sure, yeah. I think CS3 is a great place to connect with other people who have similar motivations as you and might be in a different discipline. So I've made, even as a faculty member, I've made so many different connections within CS3 from all walks of life actually, that have really inspired me to just do better work. So I think if you're looking for collaborators, or if you're just looking for more inspiration, or even if you're looking for that sense of community and other people who are also motivated in some of the ways that you're motivated, I would use CS3 as a community to do that and to engage.
Yeah, I agree. I think it's an awesome community, and there's lots of, you see whole spectrum of challenges across different fields, across between more abstract to practice. I guess my advice though to students would be to keep your head down, because there's FOMO, right? There's fear of missing out. You see everything going on, and I think as a student you should pick something important and really focus on that and become the expert in that. And you should be aware of the larger context of what's connected to and how it works. But I think there's so many interesting problems today that you should be aware, but don't be afraid to really drill in deep into a particular topic that you're on.
So, since my students are here, I can see the change after they involve in the research activity, outreach activity in CS3. I feel very proud of Zhaobin, for example, standing here, giving just 90-second pitch. Like I was imagining when I was students standing here, my legs will be shaking all the time. So I think definitely CS3 provide a platform to give the sense of community belongings, and also to connect students with different researchers, also industry people, and also the agency people, to have a conversation so that they have a more they know advance what they should prepare themselves for. So I really appreciate that.
Thanks very much. So now we'd like to open the floor to questions from the audience.
Hi, Peter Dunleavy from New York State Department of Transportation. A lot of this fascinating, eye-opening stuff that we love to have and use. And we work on a lot of active transportation issues, bicycle pedestrian issues. And a big question is how to prioritize expenditures. And how can your technology help us do that? Expose like latent demand. A lot of it is showing where people are, but how do you show if you build it, they will come, so that we can justify where to put our money?
And so my understanding, your question about how we know to anticipate the demand after we invest in certain infrastructure, is that right? Yeah. So the classical way we do is definitely just by designing survey or questionnaires beforehand to ask for that. And definitely nowadays with all the technology, I think there should be a way we can say the mobile sensing, I think, or the wireless sensing introduced by Jason, to first understand where people are going and then what they are thinking about based on the data we have. Of course, it have to complement with all these so-called, what's that? Because there are two types of one is stated preference, one is the revealed preference. For technology, we can get revealed preference of people who actually go somewhere. But if we can complement with stated preference to see what's their desired destination, or given this infrastructure here, what's their preference? I think these two data sets could complement and make a better prediction.
Can I offer a response real quick? I think there's also value in, so these, this question was interesting because these are risky bets, I imagine, right? And I think there's a lot of value in de-risking that by investing a much smaller amount to do like pilots. So within the realm of human-centered design, one of the things that we often do in our work is we try to create essentially a snow globe for users to live in. So it's a small number of people who get to live in that possible future. And then we observe from the outside what that future is like and how that changes people's experiences. And small might be n equals 10 or something like that, but this would be a field deployment. And so we find some lower cost way of making that possible future true, like real for those people to justify a further investment. So I'd say like a multi-stage process. That way you could try, maybe a dozen different investment possibilities, a dozen snow globes, and see which ones actually have evidence that, if you build it, they will come.
So while folks are maybe thinking about what their questions may be, I have another question that is really based on Jumby's talk from this morning. So Jumby's talk, fantastic. We saw a lot of interesting work that is clearly connected to what we're doing within the center. So I'd love to hear the panel's thoughts on what are the best mechanisms for us to interface with industry in ways that are not duplicative. So, or maybe to look at that question slightly differently, where is the best place for CS3 to focus given the ongoing industry investments in similar areas? Where does it make sense for us to really dig deep? Carl, can I start with you?
Sure, that's a fantastic question. And especially hard in AI right now because there's so much progress happening all around. I think the advantage of academia is basically being more nimble and being able to move fast. We're not going to go as big scale, but we can kind of do the last question as well. We can explore and de-risk something. Well, industry is actually very good at capitalizing on something and going big, but it's harder to change direction once it has started. So I think that can be our role here, actually, and that interface is we can pilot some things. Like I love the snow globe analogy, right? And those types of questions that, maybe we don't fully know if it's going to work yet, but we can be a little bit more experimental in trying it out.
Yeah, I think I love having this community of folks from industry. I think what could be really effective here is for folks from industry to have, I guess, like more explicit wish lists. Because I know certainly as a researcher, I would be looking at a lot of those things. If every industry partner had a, well, we know what we want sort of little wish list, I think that could help us on the center side avoid, duplicating efforts, and also making sure that our research is touching on issues that are actually important for deployment.
So I would say probably we need to identify the strengths and weakness of being a researcher versus competing with industry. So we are good at probably working with one PhD student for multiple projects or the whole projects, but we are not good at scalability. And we can do technology instrumentation or design, but probably if it's widespread, instrumentation or even deployment, so that we have to rely on industry partners or agencies. So I think just try to complement.
Great, thanks. So I'm going to ask a related question connected to the community. So one of the basic tenets of CS3 is that everything we do begins and ends with the community. This is a community-first center. So that made for an interesting proposal to the National Science Foundation, because you can't, if it's community-driven, you can't specify a priori precisely the applications you're going to construct. That would violate the premise of the whole thing. So that means that we need to work with community partners to first understand the specific needs, to understand the applications, the sensitivities, the constraints, and from there we use those to identify the applications and build them out. But it doesn't stop there, right? So I mean, as we're building out these applications, even as we invest all this time to ensure that there is community legibility, the technology advances quickly, and community perceptions can change. So there could, hypothetically, there could be a security issue in a smart city application on the other side of the globe, and that can affect sensitivities here. So I'd love to hear each of your perspectives, and how do we adapt as we're moving forward with our application pilots when new sensitivities might emerge? How do we navigate that in a way that allows us to continue to make technical progress while remaining true to the community-first mission? So, Carl, can I start with you?
Yeah, thanks. It's a great question. Actually, I have a great answer. I'm going to think about it a bit. I don't want to put Brian on the spot, but I was thinking Brian is a great person to answer this question. But maybe he's going to punt on it too.
Carl and I are just down the hall from each other, so we. Yeah, I think the way that I think about it is part of our research will be in creating a new effective process itself for incorporating community input throughout our work. And so I can foresee in the years to come, and hopefully this is 2 or 3 years and not more than that, us actually creating some new technologies for soliciting opinions and feedback on the ground, perhaps repurposing these Link NYC kiosks as very easy, low friction ways for people to just speak their mind as they're walking by. And for that data to be understood by large language models and coalesce together so that researchers and cities alike can just get a better bead on what people are thinking and what problems are in the forefront. So I think there's a lot of research innovation even in how we solicit feedback from the community. I'm excited to continue thinking about that.
Can I just respond to that? I mean, it's great to have community feedback, but how are you going to reconcile the community being wrong? Famously, you have a lot of NIMBYism. People don't like change. We all have iPhones. Famously, nobody could conceive of why they'd want an iPhone in 2006. So how you obviously we want to get community feedback, but how do you reconcile the fact that the community might be wrong?
I guess I don't see it. So thanks for the question. I thought Carl was tough. Just kidding. I don't necessarily see it as a community is right or community is wrong thing. It's more about, like, from the human-centered design perspective, it's about, like, what is understanding what the community is valuing at this point in time. And making sure that as we're creating new technologies, that it aligns with those values. So even if, let's say, just like the street camera, just to be concrete here, the navigation assistance for blind pedestrians using street cameras, let's say the community says, no, not in our backyard, no way whatsoever. In that case, it's important to dig into, like, well, why does that matter? And then more likely than not, it might, like in that case, it might matter due to privacy or security concerns. And we're doing a lot of privacy and security research within the center. And I think there are ways that we could use street cameras, and even I could be involved, even, it might not apply for accessibility purposes, or maybe the accessibility question becomes access to a sense of security. And focusing on new ways for individuals in the community to, like, express, I don't want to be seen on camera, and pivoting around that. I think there's still a lot of ways for us to just, like, to move forward with like figuring out what a smart city should be. Even if we get some curveballs and, like, oh wow, like this is what people are valuing right now. I hope that answers your question.
I'd just like to add to that. I think that your point on what does the community value now is this temporally changing phenomenon is incredibly important, and I think it can work in both ways, right? So you can have incidents that change the community's perspective on applications that are being rolled out today from positive to negative. That can happen. But we've already seen shifts in community attitudes in the opposite direction. So we've done intercept surveys. We've been engaging with the community for several years now. And initially, when we speak to the community about artificial intelligence in particular, how do you feel about AI? Quite often the answer was, I don't like it. What is it? I don't know, but I don't like it. I'm uncomfortable with it. How do you feel about computer vision? I'm not excited about computer vision. But then in one of our test beds, there was a serious crime that was committed. And the community came back to us and said, we are interested in computer vision if it can help to reduce crime. So you can see these interesting shifts from positive perspectives on technology to negative, and vice versa. I think Brian's point of ensuring that there are mechanisms within the center to ensure that we are all in tune with the current values of the community is incredibly important.
So I'm an audience member. I just have a question, if there's no other question right now, and it's more on a pedagogical perspective, and just want to touch on a couple things that Carl mentioned, and actually Sharon as well. So I'm looking out, the School of Engineering is over here. We're not probably ever going to be a school of AI, but there is definitely a trend for AI to kind of supplant other basic knowledge, and there's actual laws of physics that govern the world. And I'm just imagining as a student today, undergraduate, graduate student, there, and Carl mentioned the FOMO idea. It must be confusing, I think, because one wonders, should I, even if I'm in a domain, should I be expert in AI to supplant, the basic knowledge? And I think this is probably important to employers as well, that who is going to be graduating, how do we prepare our researchers and engineers of the future with still that important, this is a biased question, physics-aware learning models potentially, which could be potentially obviously a lot more reliable, more efficient. They have a lot of benefits, I would think, but please challenge that idea if I'm wrong.
Maybe I can start. So yeah, we've also been debating about that. So whether my students should just do pure AI research, or whether domain knowledge actually still applies. So I think AI is good in the sense that everyone speaks the same language. When someone saying N or CNN, now everybody knows what that stands for. But if I say in transportation, we have say ATSC, so probably nobody here knows what that means. It's adaptive traffic signal control. That's so basically, in this sense, so everyone knows how to train your network, deep models. But as I think in Carl's presentation, he pointed out, you need really the AI can understand the physics. And to do that, so students also how to have the domain knowledge as a foundation. So that's why we do this research in so-called physics-informed or domain-informed or guided machine learning, which I think will never die out, at least, at this stage. Thank you.
Maybe I can, so I think probably the biggest breakthroughs will be the surprising ones. And so it'll probably be done by a student who doesn't listen to any of us on the panel here, and just does something complete out of the box. That's always, I mean, I guess the example I want to mention is when Jeff Hinton wrote in 2012, I think was, kind of started the deep learning revolution that we're in, right? Neural nets were an old idea or a failed idea, and so to speak, and it was not out of it. And Jeff Hinton had this undergrad student, Oshkar Kureski, who just had this idea of, let's just take this old idea from the 80s and put it on a GPU. And that just changed everything, right? And the field was not looking at neural networks at the time. It just was this surprising idea out of left field, which was put it on a GPU, and look where we are today, right? So I think the next transformation will be something like that, where someone's going to have this odd idea that seems kind of unusual, and but it's going to change everything, right? And I think to your question about, what if the community's wrong in some ways? It's that diversity of ideas. I think that's the advantage of a community, actually, is that there's many different ideas going, and there'll be disagreements, and that's actually a good thing in some ways. And we'll work out to develop the big innovation. So
Andrew, to your question, should students sort of abandon basic principles and focus much more heavily on AI? About 8 or 10 years ago, students used to ask a similar question in class, and I expect everybody here had the same kind of question. Should we be focusing on AI, or phrased differently, are you worried about AI and it being disruptive to academia, to the job market? And I remember saying 8 or 10 years ago many times, AI has trouble differentiating cats from dogs. I'm not terribly worried, right? Well, things have changed quite a lot. So the tools, all of a sudden, these tools can do things that I think the vast majority of folks didn't think they'd be able to do for another 10 years, another 15 years. So I think the advice that I would offer to students is, of course, you should not give up on basic foundations and basic skills. But I do think that AI, particularly the generative tools, are becoming a new basic skill. So we saw these arguments that computer science specifically, was going to become a new required skill set. This was the big White House initiative for CS for All, right? That computing is a new basic skill. I think AI is a new basic skill. I mean, you see AI being used in middle school classrooms and seeing it used in powerful kinds of ways. So suddenly you're looking, I mean, the sort of the joke is, so my wife's a principal at high school. And so, of course, she reads lots of student essays. And by gosh, wouldn't you know that the quality of the essays has gotten way, way, way better in the last few years. So I think that this is a radical shift, but it doesn't supplant basic skills.
Thanks. How you doing? First of all, just amazing, your panel. And Jason, you have the best hair in the whole place. Just best head. I wanted to go on something that Carl had said and all of you had said, but innovation, all of this, the students and everybody that's spoken, and Carl said how you do things on a smaller scale here, and you have these great innovations that people come up with, and then how do they get them out into the market? Like, how does it become commercial? So I, believe it or not, I've been a product developer my whole life, and I've been on Shark Tank twice. I sold my soul to the devil. But I realized at a really young age, I had to put my own money into it if I really wanted to get traction. And I really wanted to get a product out there, I had to do it myself because I wanted to see what it would be like to get it commercialized. Now, in today's world, there is so much innovation coming out of universities and students, and they've got such great ideas that part of me thinks that, you know, the disconnect is how do you get to a bigger entity? How do you get to a corporation that says, you know what, I like your idea for digital twin. I like your visual, all of the things that you're doing, even your smart cities. You're actually doing stuff, Jason, that's really incredible out in the community, but I hate to see that some of these things go into the product graveyard, these great ideas, and people lose their confidence because I guess my point is that universities might have an opportunity to, on a small scale, like Carl said, to build products, to actually make them somewhat commercial on a smaller scale. So I'm wondering where you guys stand on keeping the confidence up for these developers, these startups that have great products, but they just don't have the finance to go to the next level.
So I'm happy to turn it to the panel if anyone would like to respond. But I was actually hoping Dimitro, if Dimitro is in the room, might respond to that. So I think Dimitro's shaking his head no.
Great question. Sorry, I was just emailing away. But that's a really important one because the danger of the amazing deep research, one of the dangers is that it stays amazing deep research and never leaves the construct of the lab. And then there's the disconnect with the community and with the society and with the marketplace. You have that hammer looking for nails, right? Or you develop something that has an idea but just doesn't have the scientific backing and never reaches the escape velocity, right? So you need the science and you need it to be connected to the marketplace and to the society. Thankfully, it's 2024, and I would argue with over a decade of elements like iCore, where you are introducing these concepts for the first time of what is the unmet need that you are solving. What is the value proposition that your solution is proposing that others don't? And then you're forcing people who are scientists predominantly to think outside the box, right? Like still use the scientific method of making an observation in a not closed system, but on the business side. So these are the elements that you're doing on educating through elements of iCore, deep diving into the domain expertise on smart cities, on specific technologies, layering the mentor component to this, people like yourselves, and would love to talk more afterwards how we could engage people like you to lend some of that support, and then some funding. So like that is the layer cake that oftentimes tends to be a solution for first-time researchers, you know, orienting themselves on the commercialization path. I'll talk more about this in a later session on the demo day, but really excited about this happening in New York, in the US, but all over the world, and specifically at CS3 as well. Thank you.
Thanks, Dimitro. Carl, Brian, Sharon, thanks so much.
So next up is lunch out in the lobby there, and also our student posters are on display. So we have an hour for lunch, and apropos of Dimitro's comment, we're actually going to resume with our accelerator demo presentations at 1:25.